Today we are going to prove congruence using CPCFC. Okay, now a little more specifically, okay, we've got some various shapes, but a lot of them end up being triangles. Not all of them, but a lot of them. So let's first talk about congruent triangles. Okay? So congruent triangles, they have the same size and the same shape. Now what I mean by that is a right triangle and a right triangle, a scalene and a scalene, an isosceles and an isosceles. They're two of the same exact type of triangle. Okay? So this means that all corresponding parts are congruent. That means angles and sides. Okay? Right here I want you to write congruent figures. Sometimes you won't have a triangle. Sometimes you'll just have some sort of shape. Okay, so congruent figures. That also means same size and shape. Okay, all corresponding parts are congruent. If you are talking about CPCFC, see that F right there? That means you're talking about congruent figures. We're on page 8 in our notes packet. But there's a new one that I want to introduce you to. And I want you to notice that the F has been replaced with a T. So instead of corresponding parts of congruent figures, we're now talking about triangles, congruent triangles. It's the same concept, but this acronym right here, we use it when we're specifically talking about triangles, and this acronym is when we're talking about all the other shapes on the planet. Okay, we've talked about congruency statements, and I did one in the warm-up today, and I strongly encourage that you make sure that you know what is congruent to what. Because 9 times out of 10, that's where the mistake is made, not in the other understanding. Okay, so then I actually just talked about this a second ago. CPCTC. So corresponding parts of congruent triangles are congruent. Are you okay with my abbreviations? I don't like to write all those words out. So if you're good with my abbreviations, you are welcome to use the same thing, or you can write the words out. You can write congruent and triangles and congruent. Okay. So again, I want to go over some congruency statements, because this is important. The other day when we were doing the highlighter worksheet and the 5.3 notes, I was trying to make the connection that I don't need to draw a picture. I literally, if you want to call them rainbows, I don't care what you call them, but you literally can just match up the letters in the order. Okay, so J goes with P, K goes with Q, L goes with R. So let's write that down. Angle J is congruent to angle P. Angle K is congruent to angle Q, and angle L is congruent to angle R. So those are my angles. The letters go in order and they match in order. Now as far as the sides are concerned, I can start with JK, the first two letters. That would be JK here, and that would be PQ for the other one. Okay, then I can choose KL. So KL, that would be my second set of letters. I'll use blue here for illustration. So KL is congruent to QR. And then if I start with L and I go backwards, right? So LJ, then over here I would have to start with R and go backwards to P. Everybody see the congruency statements? It is so important that you can do that. Okay? I'm not going to do this one because this is the second one today in class that I've done. I think 2 was good. All right. And here, they've already got everything kind of written out. This is our triangles, and they are telling you what letters go with what letters. So K goes with A. P, I'll use green. And this is Y. I don't care what letters you use. If you don't use letters or colors, I don't care what colors you use. If you use colors, you don't need like the little markings. But if you don't use colors, then you would need to put the markings on them. Okay. We know that KM is this long one, and it's in between my pink and purple arcs. So this one would be in between my pink and purple arcs. I have a green purple here, a green purple there. I have a pink green here and a pink green over here. I still do my sides. And now I can come over here and just fill it all out. KM is this one, and it goes to AC. I have to have the letters in the correct order. Please do not write CA. Okay. And then the next one, CY, and that would be MP. We have PK, and that would be YA. That's another reason why I like using the colors to identify the angles, because I know I'm going from a green to a pink or a purple to a green or whatever. Angle Y is congruent to angle P. Angle K is congruent to angle A. Angle ACY. So I'm talking about going from A all the way to C, all the way to Y. I'm going to talk about that angle right there. That will be congruent to, this was pink and then purple and then green on my paper. So here I can go from pink to purple to green. So that would be K, M, and P. All right, now here's some triangle congruency statements. If I do MPK, first of all, I want you to notice the letters are going backwards from here. Do you guys see that? It's right there. I can go backwards from here, right? I could also use the diagram. Okay, MPK, then I have to do CYA. Triangle CYA. If we do Y and then A and then C, then I have, so I'm going from Y to A, back again to C. I'd have to start with P, go to K, and back again to M. So triangle PKM. In other words, it doesn't matter what letter we start you with. you should be able to give us the congruency statement. Okay? All right, moving on. Now we're going to practice some proofs together. Unless you have taken a test on proofs and you have 100 on it, I really need you to follow along with the proofs. Okay? So here they are, and they're not hard, but there are certain things I want you to do because that will make sure that they're easy. All right? So here we go. We're going to write the proof. Now, these first two, I was nice. I gave you those statements. You just have to come up with the reasons. But I want you to look at number 3. I didn't give you the statements that time. And then number 4, did I give you statements? Oh, number 4, I didn't give you statements either. Okay, it'll be fine, you'll see, but we got to do a systematic, logical order of progression so that we get it. All right, right here, this says that triangle ABD is congruent to ACD. So here's what we're going to do. Angle A is congruent to this angle A. Angle B is congruent to the angle C. Angle D is congruent to the other side of angle D. So I've labeled my angles. This right here allows me to mark all the corresponding parts. All right, A to D is reflexive. It's congruent to itself. I'm just going to put one tick mark right there. A to B and A to C, I'm going to put 2 tick marks because these are corresponding and they're congruent. And then BD and CD. I've got everything marked. There's not one more thing I can put on that diagram. Everything is good. Okay, so the first thing you do, step 1, you label the diagram. So back when we were doing angles and lines, so many of you on a test would not label the diagram even though it was part of the point system in the test. You have to label the diagram for a proof. Otherwise you have no idea what you're doing. Okay, it's easy to get lost. So you will be required to label the diagram. It will not be an option. Let me say that again. It's not an option. You have to label it. Then, step 2, you're going to write down all your given information. Step 2, you're going to write down all given information. So here you can see it written in statement number 1, and the reason is given. Easy breezy, lemon squeezy. Okay, now, this right here is that right there. Yes? Okay. So, right here, it says that BD is congruent to CD. So we have a new acronym. Well, actually, it's an old acronym, right? But we're specifically talking about triangles. So I'm going to put, if this side here is congruent to that side there, corresponding parts of congruent triangles are congruent. Everybody see what I just put down there? Corresponding parts of congruent triangles are congruent. Now, if these two are congruent, they are the same size, they're the same shape, what does that make D? If these are congruent, what does that make D? Makes it a midpoint, right? That means D would be halfway in the middle, yeah? Okay, so D is the midpoint of the entire thing. B to C, that would be definition of midpoint. Everybody see that? Okay. How was that? Is that okay? All right, let's move on to the next one. The next one is not a triangle. So it's a quadrilateral. It means 4 sides. So let's go through. It says quadrilateral JKLM is congruent to quadrilateral NPQR. I'm going to do something right here. This says JKLM. This next one says NPQR. I wrote that because those are the angles that match. All right, so angle J and angle N. And then I have K and I have P. And I'm just marking my diagram. I'm going in order. Angle L and angle Q. And finally M and R. So all of my angles are labeled. So that means, do you see how K is a 2 and L is a 3 mark for my angles? I'm going to put a little 1 tick mark in between those, and then I'm going to come over here and do it the same position. So these 2 lines get 1 tick mark. Then I will go here and put 2. Here I will put 3, and here I will put 4. So I'm going to match the rest. Okay. 1, 2, 1, 2, 3, 1, 2, 3, 4. So I'm matching all the sides and I'm matching all the angles. Okay, the other thing that it tells me, you see this right here? It tells me that J is congruent to K. So let's think about that for a minute. If J is congruent to N, and J is also congruent to K, then J is also congruent to P because P and K are congruent. So these 4 angles that I just highlighted in yellow, they are all congruent. J is congruent to N, that's corresponding parts. Now on the same triangle, J is congruent to K. K and P are corresponding, but this is the same size as N, so J is also congruent to P. How do you like all that? All right, so here we go. We have to prove that J is congruent to P. Isn't that fun? Okay, here we go. Quadrilateral, JKLM is congruent to quadrilateral NPQR. That is given. And I'm going to put a little check mark there because I know I've accounted for that. And I'm going to go to the next piece right here. Angle J is congruent to angle K. That is also given. Okay. Well, if those 2 triangles are congruent, why are K and P, what would be the reason that those corresponding parts are congruent? Because corresponding parts of congruent figures are congruent. This time I have an F because I'm not talking about triangles, I'm talking about figures. Okay, you don't need to flip your page. I'm going to flip it for you. But way back here, remember this? If this side is equal to that side, that's congruent. If this side and this side are congruent, and then this side is congruent to the second side, and then the last two and the first and the second are congruent. The second and the third are congruent. So the first and the third are congruent. Do y'all remember this? It works the same thing with your angles. So I want you to look here. Okay? Okay, right here. First and second, second and third, first and third. Y'all see how I did that? That's really good to kind of make a note of. This would be transitive. Transitive property of congruence.
So did you use figures because those are not triangles?
Yep. That's why I highlighted the F. Versus up here, that's a good point. This is a T for triangle because that's what we have. Right? Here, I don't have triangles, but I have figures. And it doesn't matter what the figure is. There's like a bajillion shapes. All right, are you ready for the next one? Now this one, we have to do everything ourselves. Are you ready? Okay, here's my little shape. These are triangles, by the way. And it says that triangle SVT is congruent to triangle SWT. So, right here, angle S is congruent to this other angle S. Angle V is congruent to angle W. And then angle T and this side of angle T are congruent. So I've just marked all of my congruent angles. ST in the middle is reflexive. It is congruent to itself. So I'm just going to put one little bitty tick mark. And then on this shorter side, I'll use 2 because I have room for it. And then on this longer one, I will use 3 because I have room for 3 there. Okay, so I have everything. And this says to prove that ST, that's this line right here, prove that ST bisects angle VSW. That's going to be down here. So I can write that ST bisects angle VSW, and I'm going to leave the reason blank for right now. I'm going to come back up to the top and I'm going to write my given statement. Triangle SVT is congruent to triangle SWT. All right, that would be given information. All right.
So the first thing you need to do is just write what is given in the list.
Yeah, you always, the first statement, you always write what's given. No matter what. That's what you start with. So no one should ever get that first row incorrect. Okay? All right. Something that I can talk about right here. Do you see how that is reflexive? That line is cutting this big angle here, right? This big angle S, it's cutting it exactly in half. Do you agree? Okay. Well, let's talk about ST. ST is congruent to itself. Why? I just said the reason. Why? Yes, it is, but why is it congruent? It starts with an R. Reflexive. Okay, that one, super easy. Okay, now, if that line bisects that angle, then what do I know about each side of those angles? They're the same. So this angle right over here, that is angle VST. That's this one. That is congruent to this one here. So that would be angle WST. Now I can't talk about the bisector right here. I have to talk about the fact that that side of angle S and that side of angle S are the same. So that would be corresponding parts of congruent triangles are congruent. Okay, so that angle over there and that angle over there, and we had already marked them as congruent angles. Corresponding parts of congruent triangles are congruent. And because those two angles are congruent, that line is a bisector. Definition of angle bisector. That's what that line is. So I just proved it. Okay, when you're ready, I think we have one more, right? We just have one more? Okay.
So why wouldn't we use any of the other angles to prove that?
Because we're talking about VSW. So I'm talking about that ginormous angle right there. I'm trying to prove that this line cuts that big angle in half. So that's the angle that I'm focusing on, this big angle right here. And in order to prove that that line does indeed cut that big angle in half, I have to go in and say, well, that line is congruent to itself, and this side, right, so that side of the angle and that side of the angle, those are congruent to each other. So I have a big angle that has two congruent halves, because corresponding parts of congruent triangles are congruent. And that makes this line right here the split, makes it the bisector. That's a good question. We're not talking about any of these other angles. So that's actually probably something really good to know, is like, well, what am I actually focusing on, and highlighting that big one in orange. Okay? All right, last one. Ooh, back to quadrilaterals. All right. Quadrilateral ABCD is congruent to quadrilateral EFGH. All right. A is congruent to E. Do you agree with that? And then I'm going to move over to B, but this time I'm going to put like a little line there. B is going to be congruent to F. Now I'm definitely making a big assumption that those are right angles. I don't know that they're right angles. I'm just using boxes because it's easy. C, here I'm going to put two of them. And that's going to be congruent to G, so I'll put two there. And then finally, D, I'll put one on each side and one in the middle. And here, one in the middle, one on each side. So I've matched up my 4 corners. Great. This says that AD is congruent to CD. This AD right here is congruent to that CD right there. Everybody see that? Well, here's the thing. This has no markings and this has 3 markings. This has none and this has 3. AD and EH are congruent because of corresponding parts. This DC and this HG are congruent because of corresponding parts. Everybody good with that? Okay, so I have everything marked on my diagram. It wants us to prove that AD is also congruent. So I need to prove this, that those two are congruent. That's what I'm trying to prove. So very first thing, let's go write our given. All right. I'm just going to put quad ABCD is congruent to quad EFGH. Okay, and that's given information, right? Guys agree? Okay, got that. And then it says that AD is congruent to CD. Again, given information. Look at that. Just marking the diagram and writing down the given information, half of my proof is already done. And I didn't have to do any work necessarily. Okay, so our job is to prove that AD is congruent to GH. We've got to prove that. So I'm going to leave the reason blank for right now. Okay, so here's the thing. If AD is congruent to CD, and that's given, right? AD is also congruent to EH. Why would parts on different figures be congruent? Why would, actually, let me, 1, 2, I need to do it this way. I need to do this one here, now that I'm thinking about it. There we go. Okay, I got everything marked. These are congruent, and we're trying to prove the yellow. So I've already talked about AD and CD. Let's talk about shape to shape. So I'm going to do CD is congruent to GH. I don't want to talk about AD on this row because I've already talked about it and I'm going to talk about it again. I need to talk about the other pieces. So these lines here, corresponding parts of congruent figures are congruent. Not a T, but an F. And then look, 1 to 2, 2 to 3, and 1 to 3. Oh, it's just like the previous one we just did. What property would that be? 1 to 2, 2 to 3, so 1 to 3. What property? Huh? What? Yeah. Y'all really should speak louder. Y'all are usually right. Transitive property of congruence. Okay?
Ms. Bailey, does it matter if we put the second step that you listed as the third step? Does it matter what order those two go in?
These two? Not really. I just tend to make it a habit that I like to cluster all the given information. I like to cluster all that given information. So the question was, would it be okay if I wrote that? Well, you're not wrong, and it could go second, and it doesn't affect anything when you change the order. But out of habit, I'm just a person that puts all my given information clustered together. Okay? If you get things out of order, sometimes it doesn't matter because the order doesn't, it's not a very specific, like this doesn't make something, like these are kind of independent of each other. That's given information. But this is true no matter what. So it doesn't matter really which one comes first. But I like to write all the easy parts first, get them all out of the way. Right?
So why did we have to prove that AD was congruent to EH? That's part of the proof.
Because we're talking, these are already compared. So since I'm comparing this one to this one, okay, and then I'm comparing these two here because I'm trying to prove that this side and this side are congruent. This, I could write that if I wanted to, but it doesn't have any bearing on anything. It's just marked on the diagram. I don't have to include it because it doesn't have anything to do with this. I'm trying to prove that if that's congruent to that and that's congruent to that, then these two are congruent. So EH, that's just extra info. That's actually a good question. All right, so you guys have an assignment, and I want you to look at it. So on the front, you have been given some congruency statement stuff. So kind of like our warm-up. How many of you are good with stuff like that? You're like, I get that. Not a problem. Okay, just writing down things that match. Okay, now take a look at the bottom right here. Okay, what does that say? It says each option for the proofs are in the bullet points below. So do you see all these? You see all these right here? That's the answer bank for the backside. Just so you know. That's the answer bank for the backside. Now here's the thing. How many givens do you have? You have 4 givens. How many CPCFCs do you have? You have 4 of those. Look right here. This says segment bisector, but that says angle bisector. Do y'all see the difference? Okay, so this is for angle, and this is for segment. And then there's only one back here that is like a triangle, right? And I don't see CPCTC, but I want you to realize that if the figure is a triangle and you were to write CPCFC, would that still be true? Yes. Okay? So one of them does involve a triangle. If you can remember to use a T instead of an F, fantastic. If you just use what the answer bank has, that's okay too. It's interchangeable. Tomato, tomato.
Would it be helpful for them to just cross it off once they use it each time?
I probably would cross it off. Each time I use it, I would probably cross it off. Everybody good? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one, I think I forgot to take that one off because I believe it is right here. That one there, see that? So, I don't think you need that one. I think I just forgot to delete that. If you find the proofs intimidating, you got 10 minutes and I would start on that side. Okay? I would start on this side. Okay?